Hello friends, I am Vivek Kumar, Assistant Professor, Department of Electronics, Faculty of Engineering, Gurukul Kangra University, Haridwar. So today friends, we are going to discuss a square wave generator. This is the circuit of a square wave generator. Here two resistors are there, R1 and R2. R1 and R2 resistor. One feedback resistor R. This is feedback resistor. This is capacitor connected to inverting terminal of the operation amplifier. The resistor R1 and R2 are connected as potential divider biasing circuit. So the feedback or the voltage drop across R2 resistor, the voltage drop across R2 resistor is going back to the operation amplifier to positive terminal of the operation amplifier. The feedback fraction beta is defined as R2 upon R1 plus R2. So this is the feedback fraction. This is the factor through which the voltage is providing back to the operation amplifier, to the positive terminal of the operation amplifier. Now you can see the voltage output V0. This is the voltage output V0. At t equal to 0, at time t equal to 0, let us say the output of operation amplifier is plus Vsat. It may be minus Vsat also, depending upon the situation, but I am assuming in starting that the output of operation amplifier is plus Vsat. Now when the operation amplifier output is plus Vsat, this is plus Vsat here. Plus Vsat at t equal to time 0. This Vsat tends to establish a voltage across this resistor R2, and this voltage is given by the formula Vsat upon R1 plus R2 into R2, where R2 upon R1 plus R2 is beta. So voltage feedback to the operation amplifier is beta times V0, beta times V0. Now as the output of operation amplifier is plus Vsat, so the capacitor starts charging. This capacitor starts charging through this resistance R. So this is the charging path of the operation amplifier. Here we are taking output of capacitor as Vc. So this is the output of capacitor Vc. This will be positive polarity, this will be positive polarity, and this will be negative polarity of the capacitor output. It is the output of the capacitor, that is the charging or discharging of the capacitor will be defined as the voltage across this capacitor. Now when output is plus Vsat, capacitor will start charging through this resistor Rc with time constant Rc, R into C. Because the charging of capacitor is exponential in nature, so it will be exponential in nature. This is the charging path. So capacitor will charge up to the maximum potential or the maximum voltage which is occurring at this point V0, that is plus Vsat. So it will charge up to plus Vsat. It will charge up to plus Vsat. We will define the value of this beta times Vsat, why it is charging, why it is starting charging through or from minus beta Vsat. But let us say it starts charging, right? So it will charge up to plus Vsat. but in between the potential of point 2, that is the inverting terminal, and the potential of non-inverting terminal, that is potential of terminal number 3. This will decide the output of the operation amplifier, that is the voltage difference between these 2 points, points 2 and point 3, that is VID, that is the potential difference between non-inverting terminal and inverting terminal, will decide the output of operation amplifier. So as the potential of inverting terminal, that is terminal number 2, will increase from value beta V naught. So there is a VID, the VID, that is potential difference between positive terminal and negative terminal, will be less than 0 in this case. So output of operation amplifier will be directly minus Vsat, because the gain of operation amplifier is very high. So if VID, that is potential difference between positive terminal and negative terminal, that is potential difference between non-inverting terminal and inverting terminal, becomes less than 0, the output will saturate, or the output of operation amplifier is saturate directly to minus Vsat, that is minus V saturation. So it will be directly coming to minus Vsat. It will directly come to minus Vsat from plus Vsat. So this is the saturation voltage. This is the saturation voltage, that is output of operation amplifier, and this curve is potential of, or the voltage across capacitor. Now as soon as the output goes to minus Vsat from plus Vsat, the output becomes minus Vsat here, this becomes minus Vsat here. So the output across this resistor R2 will also change. The output across this resistor R2 will also change. Now it becomes minus Vsat divided by R1 plus R2 into R2. So this is now V reference become minus beta times V naught. Obviously, because the potential of this point of cross capacitor is 0 and the potential of other terminal is minus Vsat. So this capacitor will now starts discharging, and it will discharge up to the maximum negative voltage that is incurred across the output of the operation amplifier, that is minus Vsat. So it will discharge up to minus Vsat, the maximum negative potential. So in course of discharging, now it is discharging from plus beta Vsat to minus beta Vsat. It will discharge up to this point, rather it will discharge up to minus Vsat, but at this point minus Vsat, transition will occur. Transition will occur means the potential of point number 2, is now more negative than potential of point number 3. So in this case, the VID, that is the potential difference across terminal number 3 and terminal number 2, that is VID, is now greater than 0. That is the potential difference across operation amplifier or input of the operation amplifier is now greater than 0. That is potential difference across non-inverting terminal and inverting terminal is now greater than 0. So output of operation amplifier will directly saturate or directly change to plus Vsat. So now this is at this point, at this transition point of time, the output of operation amplifier will change directly to plus Vsat. So output of operation amplifier becomes plus Vsat. Now again this terminal of a capacitor effectively becomes positive and this terminal becomes negative. Now again capacitor will start charging toward plus Vsat. So it will charge again to plus Vsat. it will charge rather up to here, but at this point transition will occur, because at this point again the potential of terminal number 2 becomes greater than the potential of terminal number 3, that is VID becomes negative here again. So as soon as VID becomes negative, it will again discharging, it will again starts discharging, and it will discharge up to minus Vsat, but at this point transition will occur. So at this point again it will be charging. So this process continues, and this will be providing a regular output. So this was the basic mechanism of the square wave generator. Now coming back to its derivation, because we have to calculate the time period of the square wave, this time period t. So we have to calculate ultimately the time period of the square wave. So now let us calculate the time period of the the time period of the output waveform, that is a square waveform. Friends, we know for any charging system or any capacitor system, the capacitor will charge or discharge according to this universal formula. This is universal formula VCT, where VCT shows that VCT, that is output across capacitor, is equal to V final, that is the potential up to which the capacitor will charge, plus V initial minus V final multiplied by exponential e power minus t by RC, where t is the time and RC is the time constant. Now V initial is the potential of starting point. So V initial is the potential of starting point. Sorry friends, this is fluctuating. Okay, right. So now this is the capacitor across, this is the output across this capacitor. So this capacitor output is defined by this formula. Now there are two cases when V naught is plus Vsat, we have discussed. So capacitor C charges from minus beta Vsat to plus beta Vsat and switches V naught to minus Vsat. Likewise, when V naught is minus Vsat, capacitor charges from plus beta Vsat to minus beta Vsat, as we have discussed here, just discussed. Now the charging and discharging of a capacitor is defined by this formula. So we can define the one half cycle or the full half cycle rather by applying this formula. So we can apply this formula. So VCT, the capacitor voltage VCT is defined as V final. This is V final plus V initial minus V final. V final plus V initial, that is minus beta Vsat, minus V final, that is Vsat, into e power minus t by RC. So the output across capacitor is defined as VCT equal to V final, that is plus Vsat, plus V initial minus V final, that is minus beta Vsat, that is from which the capacitor is charging, the starting point, the starting potential minus beta Vsat, minus Vsat, that is the final potential Vsat exponential minus t by RC. So this will give you simply plus Vsat minus Vsat 1 plus beta exponential t by RC. Just solving this equation. Now at time t equal to t1, that is half cycle, we can see from diagram at time t equal to t1, that is from 0 to t1 point, this point, the half cycle of the square wave. So we can apply formula for this time period, that is from t equal to 0 to t equal to T1. Applying this formula, we get at t equal to T1, the voltage across the capacitor reaches plus beta Vsat and switches voltage Vc at time T1. So at time t equal to T, the output of the capacitor is plus beta Vsat, as we have seen, equal to Vsat into 1 minus 1 plus beta exponential minus T by RC, just by this expression. Solving this equation, we get simple solving. We get 1 minus beta equal to 1 plus beta exponential T1 by RC. So T1 is the half time of the output square wave. So solving this, we get T1 is equal to RC natural log 1 plus beta upon 1 minus beta, and that is giving RC natural log R1 plus 2R2 upon R1. So now finally we can solve it, and again we get the total time period, that is T, capital T, is equal to 2 times T1, and this is given by simply 2 times RC natural log 1 plus beta 1 minus beta. So T is finally given by, this is T is finally given by 2 times RC natural log R1 plus 2R2 whole upon R1. So this is the total time period of the output square wave. So we can calculate the frequency of oscillation, that is given by the inverse of time period simply. So F naught is equal to 1 upon T, that is given by this formula simply, where beta is obviously given by potential divider network, that is R2 upon R1 plus R2. Considering R1 equal to R2, we can take R1 and R2 equal. So if we take R1 and R2 equal, we have the formula, that is beta equal to R upon 2R, simply because beta was R2 upon R1 plus R2. So this is simply R upon 2R, that is 0.5. So the time period becomes 2RC natural log 3. So this is the F naught. Now we can take one simple example based upon this, that is shown here. So for the circuit shown in figure 7.9a, that is the starting figure, we have discussed the figure, that is the circuit diagram of the square wave generator. Assuming R1 is equal to 116 kilo ohm, R2 is equal to 100 kilo ohm, and plus minus Vsat is equal to plus minus 14 volt. So we have to calculate the first part, the time constant to produce 1 kilohertz output, second part the resistance R, and third part the maximum value of the differential input voltage. So for first part, we have the formula, the time period T equal to 2 RC natural log R1 plus 2 R2 upon R1. So you can just put the values over here. So T equal to 2 RC natural log 116 kilo ohm plus 2 times R2, that is 100 kilo ohm, upon R2. So upon R1. So this is 116 kilo ohm. So this is simple solving, and you will get frequency F equal to 1 upon T, that is 1 upon 1 kilo, that is 1 millisecond. So this is, friends, our frequency of oscillation in the time period. So frequency of oscillation, that is F is equal to 1 millisecond. So we can simply calculate our time period. So time period is 2 RC equal to 1 millisecond. So this will give simply RC equal to 0.5 into 10 to the minus 3 second. The second part, we have to select capacitor value, because RC, the time constant is RC. So the value of capacitor is, the value of capacitor or capacitor comes in a standard form or a standard value. So we can take the standard value of the capacitor. It may be 0.01 microfarad, it may be 0.1 microfarad, it may be 0.47 microfarad, depending upon the standard value which are available to us, right. So by substituting the value of capacitor, we can calculate the value of R, because R is, whatever the value of R comes, we can set it through preset or potentiometer. So by substituting the value of C equal to 0.01 microfarad, we can get the value of R is equal to simply 50 kilo ohm. It may be 49.5 kilo ohm. So we can take a preset of 50 kilo ohm and we can just set the potentiometer setting to 49.5 kilo ohms. So the value, the different value of resistance can be set through preset, but the value of capacitor can be changed, but it becomes costly because we have to take the variable capacitor, and the variable capacitor comes costly. So we can take the standard value of the capacitor and accordingly we can set the value of preset. So this is giving 50 kilo ohm. Now the third part, the maximum value of the differential input voltage. So the maximum value of differential input voltage we can see from the diagram. So this is the starting diagram. So the maximum value across differential input, this value VID, the maximum value is being asked. So this is the maximum value is given by, the feedback value is given by beta times Vsat. The feedback value is given by beta times Vsat, that is R2 upon R1 plus R2 into Vsat. So the maximum differential voltage or the maximum differential input voltage will becomes double this voltage. So this becomes 2 times. So this is 2 Vsat into beta. So this is given by simply putting the value 2 into 14, that is Vsat 14 volt into 100 divided by 100 plus 116 kilo ohm. This becomes 12.96 volts. So this is the final answer. So friends, we have just seen, we have just understood the working of square wave generator, the derivation of its output frequency, and one simple numerical based upon it. Sometimes one more important point is here, why we started from beta Vsat. We have to start from 0 because as we switch on the device, it will start from time t equal to 0. So we can start from time t equal to 0. So this will, the charging and discharging fashion will be like this. Simply just see, this will be charging and this will be discharging up to minus beta Vsat. Again this will be charging and this will be discharging. Simply this will follow this path rather than starting from minus beta Vsat. So friend, just we cut out, or just we cut the starting part, that is from 0 to t1, this part, because in this part this is not symmetrical because it is starting from time t equal to 0. So this part becomes unsymmetrical. So we just cut this part, and to make it a regular wave shape, we just take from here or from here. So this will give, after this will give the regular waveform. That is why always the output starts from beta Vsat. So thank you friends, thank you for listening, thanks.